And we're moving on now, and we have the next speaker who is going to tell us about cases of deep learning in creating the index of health of equipment and in different fault detection and diagnosis. I'm happy to introduce you to senior employee of Higher School of Economics in AIRI, Ilia Makarov. Good afternoon. Today we're going to discuss AI in industry. My name is Ilia Makarov. I am with Atomic Industry Research Institute. During the workshop today, we're going to look into two different subjects. They're very interesting. They're devoted to different applications of AI in industry. First of all is fault detection and diagnosis in chemical process, and the other one is monitoring of equipment condition. Let's begin with looking into what is fault detection and diagnosis in chemical process and why it is important. Modern chemical processes such as processing or refinery, such as oil refinery, they are very important for our day-to-day life. But naturally, in a complicated process, they are prone to different deviations. For instance, if the raw material is changed, then the process based on certain modeling might not get adapted. It might fail with the new crude, with the new raw material. And this is why part of the product in the end might be defective and it might have to be discarded. There are lab experiments that assess the quality of this product. It's a very costly procedure. It's done once in a while. And in case if something goes wrong, then the product that had been produced is considered to be a damage and it's discarded, and it's a huge loss for business. On the other side, there is a huge enterprise that maintain these processing complexes, and they have a lot of sensors, and these sensors describe the process to some extent. So the main task here is to use the sensors and in real-time mode to see how the process is going, whether it's normal or whether something is malfunctioning. And then there are a few options, either to notify operator in the control room or to optimize some parameters of the process in order to bring it back to normal. And from the standpoint of research, it's a very great thing to look into, because it's somewhere between industry and research. Because on the one hand, there are not many open data, and on the other hand, it turns out that traditional methods that are usually used to detect and diagnose faults, they can be used in industry. For instance, our research group within the Institute is working with deep learning in order to diagnose faults. Usually AI models are taught based on sensor data from the equipment, and there is a certain prediction made whether the process is going to be normal or not, and certain deviations from the process are classified, different types of mistakes. And there is semi-supervised methods where there are some labels. There are also self-supervised methods where we can predict whether something is going to go wrong with the process or not based on the data. For instance, we can teach a predictive model that will predict faults in the future. If we see some deviations from the prediction, it means that the process has changed its behavior and potentially it might be a pre-emergency situation, and we can check it manually, or we can launch some more point-wise diagnostics. And also deep generative models. It's based on building clones. We're modeling process and we simulate the process based on generative models where we generate data and they try to predict statistical distribution of signals to eliminate noise from these signals and to diagnose the condition of the machines right now. On the image on the right, you can see a typical example of what operators usually see in control room or from the standpoint of machine learning, you have a few sensors. You have trained the equipment, and you have technical processes and chemical processes, and all parameters are fine. But in the beginning, but then some deviations begin. And there might be some uncertainty in detecting these processes, and you can minimize, and it helps minimize operation costs. It helps reduce downtime in case if something goes wrong with machinery at an enterprise. And on the other hand, it can maximize efficiency of the throughput of the operations, because you must also reduce the false alarm rate, because your system cannot be notifying you all too often, because there might be some false alarms as well. It's too panicking. Then I wanted to demonstrate a couple of videos about potential monitoring systems, what they would look like. Let's have a look at these videos together.
This is a demonstration of chemical process monitoring. On the left, we see the values of 4 out of 52 sensors. We can select a group of sensors for visual monitoring. On the right, we see the diagram of simulated chemical process and types of behavior. Type 0 is normal behavior, while other types are false. We can select the type to run the simulation of specific type of fault. For example, let's select type 1. Now, the red dots represent the detected anomalies, while the dotted green line shows a simulated normal behavior. As we can see, sensors 10 and 11 shows a significant deviation, but 9 and 12 look close to the normal.
In this example, we have considered the opportunity to monitor and control processes, chemical processes. This is one of the cases how we can apply AI. Next thing we're going to discuss is monitoring system for industrial equipment. We're going to look into two things. First, acoustic anomaly detection. So the task is that there are a lot of machines, a lot of equipment. You can install the required cheap sensors such as microphones and record the sound of machines working and tell apart the different noises that different machines are making, different engines are making, and apply standard methods of signal processing or machine learning with labels or without labels in order to detect deviations in the machines working. On the other hand, you can build a health index for equipment. It might be relevant not only for acoustic data, but also on regular sensors such as temperature measurement or pressure measurement. Health index is a very convenient visual tool for the operator. It actually predicts the rule. Rule means remaining useful life. So it can detect it can calculate the remaining useful life of equipment. It gives us a chance to assess depreciation of equipment, and we can adapt it to what we can see on the sensors in real time. On the right, you can see that in the beginning the equipment does not depreciate at all, but then in the future it starts degrading. It's depreciating, and it's important to understand. If we lose the point when it starts degrading into a pre-emergency condition, then it's a loss for business, it's downtime for equipment, it's potential accidents. If we maintain too early in order to improve performance or in order to reduce depreciation of equipment, then it will cause downtime as well, time out of service. So it's important to find this balance. To find the balance that is optimal. And we can use predictive analytics here in order not to have too many false alarms and to have data that will be reliable to maintain equipment. We believe that in the beginning, the depreciation is actually better. We consider it to be better than it actually is. Then we have degradation and we start panicking. And we predict that it's gonna get better sooner, but in the end we are matching, so prediction and actual are matching in the end. We can see that the machine learning can help us here. We can accumulate more and more data, and we can predict real condition of equipment more precisely in course of time. Let's take an example. Engines that have sensors of pressure, of fuel consumption. There are regular systems that are based on physical modeling, and they are quite difficult to manipulate in terms of optimization, and it takes some time to optimize them. On the other hand, it's difficult to optimize them and to adapt them to different engines with different depreciation parameters, with different other parameters, and they do not take into account current situation. One of the ways to apply AI here is to produce systems that are monitoring condition of machines in real-time mode. Let's have a look at another demonstration.
Showing the neural digital twin for estimating the condition of an airplane engines. Demonstration is performed on NASA's CMAPS dataset. The developed model makes a prediction based on 25 sensors of internal engine parameters. Several of them are shown in the corresponding graphs. The built model demonstrates the possibility to register the engine degradation on the fly and allows to conduct more accurate data-driven conditional monitoring, which is the current aim in the field of industrial AI.
On this example, we have considered another advantage of machine learning: prediction of health index compared to the data that we have. As an exception, I wanted to mention three main things that relate to AI application and machine learning in industry. First, approaches for monitoring of industrial processes based on data and control of condition of equipment, they are beneficial, first of all, in decision-making. Data-driven decision-making, and it's going to be more optimal. It's going to be much higher quality compared to some fixed rules and standards that are usually used in offices. When you're observing the machine, when you're detecting the dynamic of its depreciation, you can predict its condition more accurately based on the current condition of this equipment, based on the data that we receive from multiple sensors on this equipment. And we also can take into account some factors that some sensors have broken down and some sensors are not simultaneous in terms of the way they're providing their data. But this system will still reduce costs. It will detect faults faster, and it will reduce the number of false alarms, and it will work better than fixed rules that do not work optimally. As a result, we have this control system, we have predictive models, and it also supports processes, supports the condition of the equipment based on the real-time situation with this equipment. And also AI can be applied to monitor and to control industrial processes. It's not only about predictive analytics and monitoring, it also helps develop certain rules that will help engineers make decisions not only based on output of models, but also based on terms of what can be done based on deep learning, and that's considered to be a black box. And you can write requests to data, and it can be simple in terms of time. For instance, in case if temperature is rising within a certain time, or in case of pressure goes up within a certain time, and after that, the rotation of the engine is accelerating. This is a signal, this is a red flag that notifies us that the situation is pre-emergency. And it will help people make decisions based on data, and it will help detect causality. So what's the root cause? What leads to emergencies and what leads to accidents? And also we can analyze why decisions are being made and why we should make these and these decisions based on analytics and based on statistics. Because having a lot of data in the industry, you need to be able to use them right in order to maintain the equipment properly, in order to reduce cost and improve efficiency, improve performance of these machines. Naturally, ultimate goal of applying AI here is to expand opportunities to build digital clones, and first of all, a 5.0 industry, which means that according to AI 5.0, AI is helping people to make data-based decisions, but not replaces humans. It only helps humans to make decisions. This is what we intend in AI 5.0, and it also will help us work better. Also wanted to make a simple example. When we are driving on the car, on the road, we can see traffic signs. They're there to help us drive safely. On the one hand, we can drive with the speed of 10 kilometers per hour and be absolutely sure that we will not have any delays, any abnormalities, and we will be able to respond to any abnormalities. On the other hand, we can move with the speed of 60 kilometers per hour, but potentially we might miss or we might not respond promptly to some events on the road. And in this case, AI can help us. Predictive analytics can help us. It will help us make decisions faster, and computer vision will help us in this case. In this case, we have a question. What's considered to be better? What's the right thing to do to be as cautious as possible but still have some room for human factor? Or speed up and to see how automation can help us here, whether it leads to any benefits or losses for business if we introduce automation into business and move faster along the way. Our research that we're doing in artificial intelligence group AI 5.0, it helps us develop optimal control and monitoring in industrial systems, in industrial facilities, in industrial processes. And on the one hand, it gives important information for operators to make data-driven decisions, but on the other hand, it helps make decisions better based on what is happening in real time. This is the conclusion of my presentation. Now I will be happy to take your questions. The Atomic Industry Research Institute was happy to present his presentation. Thank you very much. Thank you. It was a great presentation, and indeed we have questions for you. If you don't mind, I will ask questions right now, and we'll be happy to hear your answers. The guest is asking, what's the percentage of increase of the life cycle of equipment? Have you done this measurement? If you have these numbers, can you give us the numbers? Yes, thank you for the question. We can't give one certain answer to this question, but based on the data of the engines that we have considered, we can increase the life cycle of the machine by 20%, and depreciation of equipment is delayed by 20%. Usually, we find out that machines with high depreciation level, in terms of mathematical modeling or physical modeling, it gives less accurate prediction compared to a data-based model. As to new machines and new facilities, of course, the improvement might not be that tangible, maybe 5% increase in life cycle of the new equipment, but still it's very important because on top of the target metrics that we have looked into when the equipment gets completely depreciated. Along the way, when depreciation happens, the machine is being maintained, and these parameters can be adjusted, and frequency of maintenance is directly linked to what we see on our sensors. So we can reduce maintenance, we can optimize maintenance, and we can save costs, and we can improve performance of our facility. And it's not also a percentage of improvement of ultimate matrices, but also other business matrices that are important at our facility. It helps reduce costs. Thank you. Thank you very much, Ilya. It was a great presentation. Thank you very much for giving the answer to the question. We're moving on.